Okay, so 9F and G, I'll cover them together because they both got to do with Eulerian, trails and circuit. Alright, just keep in mind, when you see the word Eulerian, it means that you cover every edge in your graph. Okay? Trail just means you start at one spot and you can finish anywhere you want it, but still you need to cover every edge. Circuit just means you start at one point and have to finish at that point, the same vertex. Okay? But the important bit is you have to cover every edge only once, but you can cover the vertices more than once. So the first one is find a Eulerian trail for each of the following. So I've just done the first one. So this is one there. So if you go to A and you go across to B, okay, so this one is a Eulerian trail, which means I'm going to start and I'm going to end at two different spots. Okay, so we're going to start at A. So I go to A, then I go to B, then I go to C, uh, like here. Then I go to D, then back to B. Then I can go down to C. Then I can go up the A and down to D. Okay, see that? I covered every edge only once, but I've started at A and I've finished at D. This is exactly the same thing. Only difference is I cover every edge, but I have to start at the one vertex and I finish at the same vertex. And that's what that sequence would look like right here. Okay, so this might require a little bit of trial and error, but long as when I say Eulerian, you want to cover every edge in your graph only once. Okay, vertices, you can cover that more than once. Okay, now with the next one, not every network or every graph is going to be Eulerian. There's a couple of small rules that we need to follow. First of all, in these three different networks, I've just worked out the degree of each of the vertices. So that's 3, degree 3. This has got 4s, 2s, and 3s, and this has got 2s and 4s. Now, in order for a graph to be a Eulerian trail, in order for Eulerian trail to exist, okay, they don't exist in every graph, you must have exactly 2 odd vertices. And the only one that has that is these ones. Okay, and with that it means you start at one odd and you finish at the other odd, but long as you cover every edge. Now for a trail, every vertex must be even. Okay, so if you look at this one here, the third one, every vertex is even, therefore this is circuit, all even vertices. You can start anywhere you want, but you have to end up back at that same spot. But remember the trail, there must be at least two, there must be only exactly 2 odd vertices, and you start at one and finish at one. Look at the first graph. Okay, can you see all the degrees are odd? Therefore, on this one, you cannot construct a Eulerian trail or a Eulerian circuit. Okay, so don't forget this covers both 9F and it also covers 9G as well. Okay, all right, thank you.